For countless generations, Betelgeuse has dominated the night sky as one of the brightest crimson stars visible from Earth. Positioned on the shoulder of Orion, its unmistakable reddish glow has made it a familiar landmark for observers throughout human history. Long before modern astronomy existed, people noticed its unusual appearance and changing brightness. Ancient skywatchers documented its behavior, sailors relied on it while navigating vast oceans, and cultures around the world incorporated it into legends that survived for centuries. Unlike most bright stars, which appear nearly unchanged from night to night, Betelgeuse has always behaved differently. At times it shines brilliantly, while at other moments its light weakens enough for careful observers to notice. Today astronomers understand that these changes are genuine. Betelgeuse is a variable red supergiant whose enormous outer layers constantly expand and contract, causing its brightness to fluctuate over time. Modern observations place the star approximately 550 to 650 light-years away from Earth. That means every photon reaching our eyes today actually began its journey several centuries ago. In a very real sense, observing Betelgeuse means looking backward through time. We never see the star as it exists at this exact moment, but as it appeared hundreds of years in the past. This remarkable fact reminds us that the farther we look into space, the deeper we peer into cosmic history. Although its surface temperature is only about 3,500 Kelvin, much cooler than the Sun's roughly 5,800 Kelvin, its sheer size makes it vastly more luminous. Current estimates suggest its radius is somewhere between 700 and 1,000 times larger than that of our Sun, depending on how astronomers define the edge of its enormous atmosphere. If Betelgeuse occupied the center of our solar system in place of the Sun, its outer atmosphere would stretch well beyond Mars and could even extend close to Jupiter's orbit, swallowing every inner planet. Few stars known to science rival its incredible scale, making Betelgeuse one of the most spectacular examples of stellar evolution visible in our galaxy. Its immense size also reveals where it stands in its life cycle. Unlike our Sun, which burns hydrogen gradually for billions of years, stars as massive as Betelgeuse consume their nuclear fuel at extraordinary speed. After exhausting most of their hydrogen, they begin fusing increasingly heavier elements deep within their interiors. Inside Betelgeuse, fusion has already advanced through multiple stages, producing helium, carbon, oxygen, neon, silicon, and other heavier elements. The star resembles a gigantic layered structure, with different fusion reactions taking place in separate shells surrounding its core. Astronomers often compare this arrangement to the layers of an onion, each one representing another stage of nuclear burning. Above these fusion regions, enormous convection currents transport energy outward. Blazing hot plasma rises toward the surface while cooler material sinks back into the star's interior. These convection cells dwarf anything seen on our Sun. Some are so vast that a single one could cover a significant portion of Betelgeuse's visible surface, making each cell larger than Earth's entire orbit around the Sun. Because these colossal currents constantly shift, the star's appearance is never truly static. Bright regions emerge and fade while darker areas move across its surface, creating an ever-changing pattern driven by the movement of superheated gas. At the same time, Betelgeuse is steadily shedding material into surrounding space through powerful stellar winds. Every year, small amounts of gas and dust escape its outer layers, forming enormous expanding shells that extend trillions of kilometers away from the star. These outflows carry elements such as carbon, oxygen, nitrogen, silicon, and many others that were forged through nuclear fusion during the star's lifetime. Over immense stretches of time, this material mixes with giant molecular clouds, becoming the raw ingredients from which entirely new stars and planetary systems will eventually form. The calcium in our bones, the oxygen we breathe, and the iron carried in our blood were all created inside ancient stars similar to Betelgeuse billions of years before the solar system even existed. In that sense, Betelgeuse is doing more than approaching the final stage of its own evolution. It is enriching the galaxy with the building blocks that future worlds, and perhaps future life, will one day inherit.